Hi, welcome to ISE503. This lecture is titled Databases Architecture Part 2, and the lecture slides are from our textbook, which is Principles of Database Management, the practical guide to storing, managing, and analyzing big and small data. So let's start. In the previous lecture, which is the part 1 of the databases architecture, we did look at some important components of a DBMS. So we did discuss about the connection manager, the security manager, DDL compiler, database utilities, query processor, and all its components. We have also seen the storage manager and all its components. So these things have been already discussed. Now let's look at the interfaces. So here are the interfaces, the data DBMS interfaces. So since the database interacts with different kinds of users, like a database designer, database administrator, the database application developer, end user, so on and so forth. So a good DBMS should provide interfaces to deal with all these different kinds of users. So here are some listed possibilities or possible interfaces, starting from web-based interface to standalone query language interface, then command line interface, forms-based interface, graphical user interface, natural language interface, admin interface, and network interface. You should remember some of the interfaces. You don't need to remember all. I would say just remember 5 of these, and their definition is self-explanatory. I don't think I need to explain much over here. So what we will do, let's have a look at an interface, DBMS interface, which is provided by MySQL Workbench. MySQL Workbench. So if you install that on your computer and run that, then you would be brought to this kind of window where you will find the navigator window. In the navigator window, you will find the management, then the instance, followed by the performance, and then you have the schemas information. In the schema, you will have the different tables. And then here you will find the query window. In query window, user can write SQL query. So if you could read this part, which is in very small fonts, it says select star from product. So this is a very simple SQL query which will return all the data from the product table. And this is where you'll write the query, and then you will run the query, and the result of that query is shown in this result window. And here you have the all the data being shown with these columns or the attributes like product number, product name, product type, and available quantity. Finally, you can see another window here, which is the log window. The log window will have all the log information, which will keep a kind of record in your session that you had in MySQL Workbench. Okay, so now let's look at the categorization of DBMS. So we can categorize the DBMS on the basis of more than one criteria, and it is the criteria that we are going to discuss in the remaining slides of this lecture are not exhaustive, and they are not mutually exclusive. What it means is that even we may have even more criteria of categorizing DBMS, right? Which we may probably not discuss in this class in this lecture. But we will look at some approaches to categorize DBMS. All right. So here we have all these, criteria. So let's look at the first one. In the first approach, you can categorize DBMS based on the data model, right? So here we will see that in more detail. Some databases, they are of a relational types. Some of those are the network type. There are some which are based on the hierarchical data model type. There are NoSQL databases. There are object-oriented databases. So all so this is how we can categorize them based on the data model, whether it is relational, NoSQL, hierarchical, network-based, object-oriented based. These are all example of data model. We can also categorize the databases on the basis of the degree of simultaneous access. Like, is that DBMS a single user DBMS, or whether this DBMS allows multiple users to use it at the same time. Similarly, we can have the categorization based on the architecture, and the last criteria of categorization is based on the usage. So let's have a look at the categorization. We will first do the categorization based on data model. So we will start with the hierarchical DBMS, because these were probably the first DBMS that were used. So the hierarchical DBMS, they use a tree-like data model. Hierarchical means tree shape. So for that reason, these data models, they use or adopt a tree-like data model. And in hierarchical DBMS, the data manipulation language is procedural and record oriented. So this procedural and declarative DML we discussed in the first part of this topic, which is the previous lecture. And yeah, so if you remember what the procedural DML is, then yeah, hierarchical DBMS, their DML, which is data manipulation language, is procedural and is record oriented. Now, because of that, it will not need any query processor. There's no query processor in the hierarchical DBMS. And yeah, there is a disadvantage here. The disadvantage is that the logical and the internal data model are intertwined. Okay, so because of which it doesn't have any query processor. So this point that we have here should be considered as a drawback of hierarchical DBMS. First, these are the DML that we have here is procedural, record oriented, which would add to the inefficiency of the hierarchical DBMS, and at the same time it doesn't have any query processor because the logical and internal data models are intertwined. The example, if you're curious to know if there to know about any DBMS which is hierarchical in nature, then the answer is yes. This IMS system, which is by IBM, is a hierarchical DBMS. IMS stands for Information Management System. Now let's look at a different kind of DBMS, which is based on the network data model. So the network-based data, the DBMS, which are based on network-based data model, are called network DBMS. Now, the first bullet says the same thing. It uses a network data model. The example is Codacell DBMS. And here again, similar to the hierarchical DBMS, the data DML language is procedural and record oriented. Okay, and here again we don't have any query processor, and the reason is that the logical and internal data models are intertwined here as well. So that's again a drawback, I would say. The example of a network DBMS, well, this is CAIDMS, which is by Computer Associates. Alright, now let's move on to the next class of DBMS, which is called relational DBMS. Relational DBMS uses the relational data model. We will spend good time on relational data models, or relational DBMS I should say, because these are probably the most popular and the most efficient I would say. But these DBMS, they also have some limitations. All those things we will discuss in more detail. So anyway, relational DBMS, they use relational data model, and as I said, these are currently the most popular DBMS in industry, and they are more popular. One of the reasons behind the success of relational DBMS is their query language, which is SQL, structured query language. Now, the advantage with the SQL is that it is declarative and is set oriented. Now, in relational DBMS, we do have the query processor, which is an advantage. Okay. And here, another interesting thing related with the relational DBMS is that there is a strict separation between the logical and internal data model, which is not present in case of the hierarchical and network-based DBMS. In hierarchical and network-based DBMS, the logical and internal data model, they are intertwined, whereas in relational DBMS there is a strict separation between the logical and internal data model. If you want, let me take you back, right? So here, if you see, the logical and internal data model are intertwined. That's the case with network DBMS. Similarly, for hierarchical DBMS also, the logical and internal data models are intertwined. Whereas in case of relational DBMS, there's a strict separation between the logical and internal data model. All right, so this is a very important difference that you should keep in mind if somebody asks you about the differences in these databases, like relational DBMS versus the hierarchical and the network DBMS in terms of their efficiency. Now, if you need you should know some relational DBMS. So here are some examples. MySQL, which is an open source DBMS, is an example of relational DBMS. It is being supported by Oracle. Oracle has another DBMS, right, which is called Oracle itself. Then we have a relational DBMS by IBM, which is called DB2. Microsoft also has a relational DBMS, which is called Microsoft SQL Server. Okay, fine. Now let's move on to another class of DBMS, which is based on object-oriented data model. These are called object-oriented DBMS or OODBMS. They are based on the object-oriented data model, and because of the object-oriented nature of DBMS, we don't have impedance mismatch. So if your host programming language is object-oriented like Java, and you are using an object-oriented DBMS, then yeah, you won't have to face the impedance mismatch problem. All right, because the way the data is stored in the host programming language as well as the DBMS, that is compatible. Now some examples of the object-oriented DBMS. We have DB4O, that's an open source. We have Cache also, that is by InterSystems. We have Gemstone S, that is also an object-oriented DBMS. I would expect you to remember some examples of DBMS, right? Like one example of the hierarchical DBMS, one example of the network-based DBMS. Relational, you should remember 3 or 4 because there are so many relational DBMS. 1 or 2 example of object-oriented DBMS. So let's see, if you're wondering like what's the situation, like are the object-oriented DBMS popular? right? So the unfortunate news is that they were successful only in niche market because they are very complex, right? So they did not succeed that much as compared to relational DBMS. Now the next category is the object relational DBMS. Now let's see what is this object relational DBMS. They are also referred to as extended relational DBMS. Why? Because these DBMS, they use relational model, but with the relational model, they also provide the additional support for object-oriented concept, right? So in fact, these object relational DBMS, or the also called as the extended relational DBMS, they are basically the relational DBMS with some support for object-oriented concepts. So here they have the DML, which is SQL, and SQL has the feature of being declarative and set oriented, which is an advantage. Okay, and now if you're wondering like what are the DBMS that are in this category, then yeah, Oracle DBMS provides the support for the object-oriented concept as well. Similarly, the DB2, uh, which is by IBM, also has the object-oriented concept support. Similarly, the Microsoft SQL Server also provides the object-oriented support. Okay, so Oracle, DB2, and SQL are the extended relational DBMS or object relational DBMS. And let's look at another interesting class of DBMS, which are called NoSQL DBMS. NoSQL stands for not only SQL. In this category, there are different kinds of DBMS. So basically, these DBMSs are used for storing big and unstructured data. So the relational DBMS is used for structured data, whereas the NoSQL database is useful for big and unstructured data. Now there are different kinds of NoSQL DBMS. So they can be further classified. NoSQL data DBMS can further be classified into the key value store, the column oriented database, or the graph based databases. Now, the focus of these DBMS, like NoSQL DBMS, is on scalability and their ability to cope with the irregular. And irregular, you can replace the term irregular with unstructured and highly volatile data structure. Okay, so if you are dealing with a data that needs scalability, your application needs scalability, and your application has the unstructured or irregular and highly volatile data structure, then probably you should go with some NoSQL DBMS. Some examples of NoSQL DBMS, we have Apache Hadoop, MongoDB, and Neo4j. These are some very popular and uh, some interesting NoSQL DBMS. Now, all these things that we have discussed till now, this categorization or these different class of DBMS were based on the data models. All right, now we would like to look at the DBMS categorization based upon the degree of simultaneous access. So in that case, we can have two category possible: single users versus multiple user system. So this concept is very intuitive, doesn't need much of explanation. But anyway, let's look at it. A single user DBMS would be one where it will allow only one user to access that at a time, right? So it will be extremely simple and probably it is intended for just one person. Whereas the more common DBMS that we see these days are multi-user systems. So in this picture that we have over here, you are looking at a multi-user DBMS system where you can mark it like 1, 2, 3. There are 3 users shown by 3 computers. They are accessing the DBMS, right? So here we have the database management system, and this DBMS actually has in this picture, the DBMS has 3 servers: server instance 1, server instance 2, and server instance 3. Now these three simultaneous user would request for database access, and here we have a dispatcher. The role of the dispatcher is to assign or to allow these multiple users to have the access to the database in a controlled manner. Okay, so now we will look at another criteria to classify the DBMS or categorize DBMS, and this categorization is based on the architecture. So the architecture could be centralized DBMS architecture. In the centralized DBMS architecture, the data is maintained on a centralized server, could be a mainframe kind of a machine. Whereas there's another possibility. The second possibility, the first one is centralized, the second one is client server based DBMS architecture. In the client server version of DBMS architecture, you will have active clients, and these clients will be requesting for data for data access services from the passive servers. Okay. Now in that client server kind of architecture, we have 2 possibilities: the flat server possibility versus fat client possibility, or the fat server variant versus the fat client variant. Now you need to understand the difference between the fat server versus fat client. So this feature of fat determines the computation. If you are putting more computation on the server side of the client server DBMS architecture, then it will be called fat server. If you have more computation at server side, then that is fat server. In the other case, if you have more computation on the client side, then that will be called the fat client variant. Now, this concept of the client-server model or the architecture can be extended to entire DBMS architecture. In that scenario, you will have a client, and the client will have the GUI functionality. And then after the client, you will have different servers, like you'll have an application server which will run the applications. There will be another server, that is database server. The database server will keep the DBMS and the database, and we can also have a web server that will allow the web-based access. So this third example is an extension of the client server DBMS architecture. Okay, so there's another possibility which is about the cloud-based DBMS architecture or cloud DBMS architecture. In this version, the DBMS as well as the database will be hosted by a third-party cloud provider. Example, like Apache Cassandra project and Google's Bigtable project. Okay, it's a simple one, but yeah, you need to remember, because I believe that these are some very important these days. Okay, so let's look at another class of the DBMS architecture, which is federated DBMS. This is an interesting class of DBMS where these federated DBMS, they provide a uniform interface to multiple underlying data sources. Okay, so because of this uniform interface that is being provided by federated DBMS, it becomes very convenient to access the data that might be coming from diverse sources. right? So it provides a uniform interface to multiple underlying data sources. And these federated DBMS, they hide the underlying storage details to facilitate data access. So in plain and simple word, federated DBMS, they make the data access extremely convenient where our data is coming from very different resources. And we have another interesting class of DBMS. These are called in-memory DBMS. Now, in-memory DBMS, what they do, they store all the data in internal memory. So instead of the slower external storage, so you can guess if the whole data remains in the main memory or the internal memory, then yeah, the retrieval would be extremely fast. All right. So in-memory DBMS, in-memory DBMS are going to be exceptionally fast compared to the non-in-memory variants. So because of their speed or the fast response time, I would say, they are often used in real-time purpose. All right, so if somebody is asking you to give the type of DBMS which will be the most appropriate for real-time purpose, you should say the in-memory DBMS. And the example of one of the in-memory DBMS is HANA by SAP. Okay, so now we will look at another different criteria of classifying the or categorizing the DBMS. So this is based on the usage. How do you use the DBMS? So online transaction processing. Okay, so what is online transaction processing? This is an important concept, useful and interesting at the same time. The online transaction processing, it focuses on managing the operational and transaction data, and the data server here must be capable of processing a lot of simple transactions per unit time. Okay, so the example of the transaction that the database server should be able to handle for online transaction processing is a kind of point of sale transactions, right? So just imagine for the former Walmart. Okay, I'm taking Walmart as an example. So Walmart has so many stores, right? In every city you would find at least one Walmart, and they have a huge customer base. And now whenever a customer is on the point of sale where the customer is uh, paying for the items that the customer has bought, then on the point of sale the transaction is taking place where the person at the point of sale is entering the information about the user, right? The items that the user bought, the location at which the user bought, the quantity of items that the user bought, right? The time and the date when when those items were bought. So these transactions are going to be simple, right? There are going to be a lot of simple transaction happening at multiple Walmart stores in maybe 1 second, right? A lot of those happening. So yeah, these kind of transactions are to be handled by OLTP, online transaction processing. Okay, so database server here must be able to process a lot of simple transactions per unit time. And the DBMS must have good support for processing high volume of short and simple queries. These queries are going to be short, simple, but too many, right? So the volume would be huge, but these queries are going to be simple. When we compare it with the other class, which is online analytical processing, then, excuse me, in OLAP, what happens here, the focus is on using the operational data but for a different purpose. What is the purpose? The purpose in OLAP is to use the operational data for tactical and strategical decision making. right? So this kind of thing will be done by data scientist or data analyst or business analyst. All right, so here it is, we will have the limited number of users, and these users like the data scientist or data analyst or business analyst compare their number in Walmart to the number of customers in Walmart, right? It's fairly simple. The customers are going to be huge number compared to the number of data scientists, data analyst, or business analyst. So that's what we are saying here. We have limited number of users, and they will, but these users will formulate complex queries. Their queries are going to be complex compared to the queries that are being handled in OLTP. DBMS should support efficient processing of complex queries, which often comes in small volume. All right, so this difference could be important and interesting at the same time. What is the difference? The difference between OLTP and OLAP. For usage, we have another class, that is big data and analytics. Right, so for big data and analytics, you have NoSQL databases, and the focus of NoSQL databases is on the flexibility. They are more flexible, they are schema-less, and the database structures. So they focus on more flexible and schema-less database structures rather. And the big data are good to store unstructured information such as email, text documents, Twitter tweet, Facebook post, etc. Right? So these are the kind of if you're dealing with the text data like email data and the Twitter, Facebook post and all, then for that you would go with the big data. Multimedia, right? So for multimedia, we'll use different kind of data DBMS. Because in multimedia, the multimedia DBMS, they should provide the storage for multimedia data that includes text, image, audio, video, 3D games, etc. And for multimedia DBMS, they should support the content-based query facilities, right? So like we do it, we may be interested in the images of say John Smith, right? So that kind of query, we are interested in the images of John Smith. So that kind of query where we are searching for an image, these kind of facilities should be provided by multimedia DBMS. Now let's look at another class of DBMS based on the usage. This is the special application. So special applications are extremely common and are used in our day-to-day life, like geographical information system, GIS. It's very common, right? So if you want to store the special data, then for special data you would use spatial DBMS. They support the storage and querying of spatial data, and the spatial data could be in 2 dimensions or in 3 dimensions. The application of spatial data is in GIS, geographical information system. Sensor DBMS, right? So sensor data is also getting a lot of attraction these days, right? So wearable devices are becoming extremely popular. The Fitbit, right? Smartwatches and the telematics data. Okay, so if you have to store these kind of data, then you'll use sensor DBMS. Sensor DBMS helps us in managing sensor data such as biometric data from wearable or telematics data. Now let's move on to the mobile DBMS. Okay, so the mobile devices are extremely, what I'll say, prevalent, right? So we have the smartphones, we have the tablets. So the mobile DBMS, they run on our smartphones, on our tablets and other mobile devices. And the requirement of the mobile DBMS is that they should always be online, they should have a small footprint, and they should be able to deal with the limited processing power, storage, and battery life. So these constraints we did not have in the other DBMS. All right, so the mobile devices, they are small in size, right? We carry them with us. So yeah, with that portability, we carry these devices with us, so that's an advantage. They are portable, but the portability also in results in some shortcomings or disadvantages. What are these? Well, these machines are, or these mobile devices should always be on. Therefore the mobile DVMS should always be on. They should have small footprint. Small footprint means they should consume less power, they should use less storage, they should consume less CPU computation, they should use less memory, right? So all these things are included in their footprints. And they should be able to deal with limited processing power, storage, and battery life. Then we have the open source DBMS, right? So the open source are the DBMS which are publicly available, like MySQL. And the advantage with the open source DBMS is that we don't need to pay for them. And then another extremely useful feature of the open source is that they can be extended by anyone, right? They can be improved, right? They can be improved by so many developers because they are open-ended. Sorry, not open-ended, they are open source. Now these open source DBMS or open source softwares can be obtained from www.sourceforge.net. MySQL, which is maintained by Oracle, is an example of an open source DBMS. Now the final slide is to conclude this chapter. This chapter which was the databases architecture. What did we discuss? Well, we looked at the architecture of DBMS, and we also looked at the categorization of DBMSs based on different criteria. All right, and that's it. Let me stop right here. I'll see you next time. Bye bye. Take care.